Welcome to Future Talk. My guest today is Jonathan Trent, founder and director of the Omega Global Initiative, which is developing new technologies to turn algae into oil while simultaneously cleaning up sewage water and producing a host of other environmental benefits. Jonathan has spent most of his scientific career doing research in microbiology, biochemistry, and nanotechnology. For the past 15 years, he's worked at NASA's Ames Research Center, where, among other things, he studied how organisms can survive in the most extreme environments on Earth, founded and led the Protein Nanotechnology Group, and won an award for his innovations in nanotechnology. He's also an adjunct professor in the Department of Biomolecular Engineering at the University of California, Santa Cruz, and he's an elected fellow at the California Academy of Sciences. He holds a PhD in biological oceanography from the Scripps Institution of Oceanography in La Jolla, California. I should also add that even though some of the initial ideas of the Omega project were developed at NASA, the Omega Global Initiative is Jonathan's private project, and he is not representing NASA on this program. Jonathan, welcome to the program.
Thanks, Marty. It's great to be here.
So what is the Omega Global Initiative really trying to accomplish?
Well, so the Global Initiative is sort of that second tier after we started the Omega project. Omega was an attempt to find a life support system for spaceship Earth. That is to say, a way to create an environmentally friendly system that produces energy, water, food, and does this in a way that is self-contained. And we've come quite a distance in doing that. And the Global Initiative is an attempt to find a place in the world where we can do Omega development even further.
Okay. And we're going to be talking a lot more about this, but before that, we have a video, an animation, showing what the Omega project is all about. Let's go ahead and roll that tape.
The project is called Omega. It's for coastal cities to transform solar energy into sustainable biofuels, electricity, and heat, to expand food production and access to clean water, to eliminate pollution and enhance the coastal environment. Ultimately, it's a project to develop sustainable green economies. Let me tell you how it works. Omega uses protected bays like San Francisco Bay, vast areas which will get even bigger with sea level rise. And most importantly, they already have wastewater treatment plants that currently dump wastewater into the bays. But for Omega, this wastewater is a resource, redirected into floating clear plastic tubes to grow microalgae, the fastest growing plants on the planet and the best producers of oil. The algae grow using nutrients in wastewater, and they use concentrated CO2 from a source like flue gas, which means Omega treats wastewater and captures and controls a major greenhouse gas. The Omega infrastructure is used for solar electricity and concentrated solar thermal. And in some locations, wave-powered generators and wind turbines will also provide power. In addition to energy, the Omega offshore platform supports aquaculture and produces high-quality food without using land and without using water. In fact, saving water is a big deal. It's estimated that by the year 2030, half of all the people in the world will face water shortages. And the current map of water scarcity shows in red that there are already many places in desperate need of clean water. Adapting methods developed for the space station for recycling water, Omega transforms wastewater into clean water using 1/3 the energy required to make clean water from seawater. Think about it. The integrated Omega components are modular, and they can be scaled up without using land. For example, the wastewater from one of the treatment plants in San Francisco will support a 1,280-acre Omega system and produce between 2 and 6 million gallons of biofuels each year. And what will be the environmental impact of a full-scale Omega system? It will be like a huge kelp bed or floating reef that will provide a place for organisms to grow and forage, a refuge and nursery for fish and birds. So it is likely to increase local biodiversity and even enhance commercial fisheries. Omega improves the environment by treating wastewater and capturing CO2. It increases the availability of clean drinking water by recycling wastewater. It supplies food without competing with agriculture. And it provides solar energy as electricity, heat, and biofuels. All things that help move us toward a green economy and a sustainable society. If you want to find out more about what we've done already to prove the feasibility of Omega, watch my TED Global Talk or visit our Facebook page.
And that was our video of the Omega Global Initiative. So Jonathan, how is the initiative actually going? Do you have any working models of it yet?
Well, so the Omega project started within NASA and was funded by NASA and the California Energy Commission. And that project spent about $10.8 million in nearly 3 years to test all the working parts, to look at whether we could grow algae on wastewater and we could make these floating bioreactors and what would the details be. Now what we're trying to do is find a place in the world where we can deploy the first demonstration project. Where would be a protected bay that we can build this thing offshore? Because up to now, the Omega project has only been in tanks, seawater tanks, and in laboratory testing.
What would it take to find such a place? Somebody would have to let you build it there. What would be in it for them?
Yes, okay. Well, what we're doing is a kind of open source outreach. In the Omega Global Initiative, we're looking for places around the world. Japan, for example, is a really ideal location. Lots of protected inland seas, cities near the coast that are already dumping wastewater offshore, a real need for an alternative energy source given that what happened with Fukushima. All of these places around the world that we can think of where there's protected bays would be potential sites. What's in it for them is green technologies, or a blue-green technology, if you will, and food and a local carbon source a use of their waste streams into turning them into biofuels and energy.
It would be good if these places that had the farms would pay for them also, I assume.
Oh, yes, of course. Well, the concept of the Omega Global Initiative is that we'll provide information, and hopefully get local people excited about building this technology, but they would, of course, also invest in making the technology real.
We have a few slides that illustrate some different aspects of the Omega Global Initiative. Can we see the first slide, please? Okay, so this looks like an overview. Exactly what is this slide telling us?
Yeah, so this slide summarizes what we just saw in the video, that the Omega system is an integrated system, and that when we think about Omega in terms of energy from biofuels produced from algae, at the same time, we should think of it as an infrastructure for solar power and potentially wind and wave, although solar and biofuels are really the best energy source. Because we're building an infrastructure offshore, we could build an aquaculture system using existing aquaculture technologies to make food. We've developed technology that allows us to recycle the wastewater as drinking water at 1/3 the cost that it would cost to make seawater into drinking water.
So the algae cleans the water that thoroughly that you can drink it after the algae?
The algae do the first stage, and then we use a combination of reverse osmosis and forward osmosis, technically, ways of making the water even cleaner. But the algae do the first step. And then finally, this has a positive impact on the environment. So as you can see, the environmental implications are really a crucial component of how the Omega system works. And when you think about all the implications of what I just told you, that can have a huge impact on local economies.